Welcome! We will explain how bread is made in a factory. This process turns simple ingredients into the loaves we see in stores. Bread in a factory looks simple. It is a basic food that many people enjoy every single day. A factory is designed to make many loaves very quickly. Large machines help people do the work efficiently and safely. The steps are clear and happen in a specific order. We will describe what happens from the moment flour arrives to the final packed loaf ready for your kitchen. Making bread on this scale is a fascinating journey. It combines old baking principles with modern technology. The goal is to create a consistent, safe, and delicious product. Each loaf must look and taste like the one before it. We will explore each stage of this journey. We will see the giant machines and the skilled workers who operate them. It is a world of movement, heat, and the wonderful smell of baking bread. From the start, you will see how raw materials are transformed. We will begin with the essential ingredients. Then we will move into the mixing room where the dough is born. After that, the dough must rest and develop its structure. Machines then divide and shape the dough into identical pieces. Each piece will then get its final chance to rise in a warm, humid room. The heart of the factory is the oven, a massive chamber that bakes thousands of loaves. Finally, we will cover the cooling, slicing, and packaging that prepares the bread for its trip to the store. Throughout this explanation, we will also talk about quality control, safety, cleaning, and efficiency. So, let's begin our tour inside a modern bread factory and see how it all comes together. The journey of a loaf of bread begins with its ingredients. Ingredients come first. A commercial bakery uses very large amounts. The most important ingredient is flour. Flour is usually made from wheat. It arrives in huge tanker trucks or in very large bags. Baker's yeast is the next key ingredient. Yeast makes the bread rise. Salt is absolutely necessary. It adds flavor and helps control the yeast. Water is absolutely necessary. Water hydrates the flour to form the dough. These are the basic building blocks, used for centuries. Other ingredients are often added. Sugar or malt adds sweetness and helps browning. Fat, like vegetable oil or shortening, can be included. It makes bread softer and helps it stay fresh longer. Sometimes milk powder is used to add richness. Many factories use dough conditioners or emulsifiers to help dough handle machine stress and ensure consistent texture. All ingredients are measured very carefully, by weight, not cups. Large scales are connected to computers. The computer calls for exact amounts from the recipe. The process is often automated. Flour might be blown through pipes. Water is metered in precisely. Small ingredients are weighed on accurate scales. Exact measuring is critical for consistency. It ensures every batch of dough is the same. Even small changes can alter the final bread. A factory making thousands of loaves an hour cannot have that variation. The recipe is locked in. Workers monitor systems, check weights and ingredient temperatures. Water temperature is controlled because it affects yeast. Once all the ingredients are measured, they move to the first machine, the mixer. Mixers are very large and powerful, usually stainless steel. They can hold hundreds, even thousands, of kilograms. The mixer combines flour, water, yeast, salt, and other ingredients into a uniform mass. This is where dough is created. The bowl may tilt to receive and then empty the finished dough onto a conveyor. The mixer follows a program, slow to combine, fast to develop gluten, the stretchy network that traps gas. Friction warms the dough. Bakers or computers monitor time, temperature, and consistency for smooth, strong, not sticky dough. Undermixing yields dense bread. Overmixing weakens gluten. After dumping, the bowl is often cleaned automatically for the next batch. After the intense work of the mixer, the dough needs time to rest. This resting period is called fermentation. In some bakeries, the entire batch ferments as one mass, bulk fermentation. Yeast consumes sugars, producing carbon dioxide, alcohol, and flavor compounds. In high-speed factories, bulk fermentation is short, often 10 to 20 minutes of floor time to relax gluten. Some use a sponge, flour, water, and yeast mixed hours early to build flavor, then added to the main mix. Temperature and humidity are controlled. Too cold is slow, too warm overdrives yeast. Bakers judge rise and texture to know when it's ready. After the dough has rested, the large mass must be cut into individual pieces. This step is called dividing. The divider pushes dough into set chambers, and a blade cuts pieces, continuously and very fast. Pieces are weighed, off-spec portions are rejected and reworked to ensure uniform loaf size. Rough pieces are rounded, rolled to create a smooth, tight skin that helps trap gas. A brief intermediate proof lets gluten relax again for easier shaping. The factory is a constant flow from one machine to the next. Finally, the dough is given its final shape by a molder. For sandwich bread, rollers flatten the dough into a sheet that's rolled like a sleeping bag, creating a fine, even crumb. For baguettes and others, molders stretch into long, thin logs. Shaped dough is placed in pans, automatically in large bakeries. Inside the proofer, it's warm and humid, encouraging yeast activity for the final rise. Dough inflates to a specific height and domes over the pan, neither over nor underproofed. Proofers may be tunnels or tall towers, but the purpose is the same: perfect conditions for the final rise. This step determines final volume and texture. The pale loaves are now ready for the intense heat of the oven. The next step. Baking is the magical stage where the soft, pale dough transforms into a golden brown loaf of bread. The ovens in a bread factory are enormous. The most common is a tunnel oven, a very long heated chamber. Pans enter at one end and travel through on a conveyor, emerging fully baked at the other. These ovens can be over 30 meters long, baking thousands of loaves per hour with multiple temperature zones. A burst of steam keeps the crust soft briefly, allowing rapid expansion called oven spring. High heat sets the crust, slightly lower heat finishes the interior. Heat stops fermentation, sets starches for a soft crumb, and browns sugars and proteins, the Maillard reaction, for color and flavor. Conveyor speed and zone temperatures are computer-controlled, while operators watch color and check internal temperatures. Safety is critical around high heat. Ovens are heavily insulated to keep heat in and the floor safer. When loaves emerge golden brown, the air fills with the comforting aroma of freshly baked bread. You know, it really is something. Bread isn't ready for packaging yet. Loaves are near boiling inside and must cool before slicing. Open, winding paths and tall cooling towers let air reach every side until room temperature, often an hour or more. Slicing warm is a disaster. The crumb is gummy and tears. Proper cooling sets structure and stabilizes moisture. Once cool, loaves feed into slicers, where fine blades cut perfectly uniform slices at high speed. Workers visually inspect and remove any loaves that aren't perfect. Machines open bags, push or puff loaves inside, remove air, and seal, often with a dated clip or twist tie. Packaged loaves are grouped, boxed or trayed, and stacked on pallets for shipment. Quality and safety are the unseen ingredients. Checks from raw materials through dough development and proof height to crust color and taste. Some factories test moisture and texture in a lab to keep loaves consistent. Hygiene is strict. Smooth stainless surfaces, frequent hand washing, PPE, daily sanitation, guarded machines, and emergency stops. Making bread is a clear chain of steps. Machines speed the work while trained people guide the process. This process ensures that fresh bread is always available. Please like and subscribe.